right now, like at this very second, there are thousands of groundbreaking scientific discoveries just sitting completely invisible on hard drives around the world.
Oh, yeah. Thousands of them. It's actually kind of tragic.
Right. And it is not because the science is bad. I mean, it's because the brilliant researchers who spent, years discovering those findings are completely paralyzed by a glowing, blank Word document.
It really is the great irony of academia. I mean, you spend months in a lab operating with absolute predictable physical precision.
Yeah, exactly.
You're measuring out exact microliters. Your Western blots are flawless. You are in total control of the physical environment. But the moment you sit down to translate that data into a manuscript,
Precision just totally vanishes.
it vanishes, poof.
Which is exactly what we are fixing today. So welcome to today's deep dive. We are taking that dreaded, paralyzing chore of writing and publishing a research paper and, well, transforming it into a straightforward, predictable blueprint.
And it really is a blueprint.
It is. And to do this, we've pulled together an incredible stack of sources for you. We're drawing on transcripts and guidelines from top academic mentors, including insights from Dr. Arup Giri's channel, writing frameworks from Dr. Elena Kalastanova, creative guides from the International Union of Biochemistry and Molecular Biology, and some very sharp behavioral advice from author Paul Sylvia.
Yeah, and what becomes immediately clear when you look across all these sources is that writing paralysis usually comes from a fundamental misunderstanding of what a scientific paper actually is.
Oh, for sure. We completely romanticize the writing process.
Exactly. Researchers often feel like they need to channel their inner novelists, like they're waiting for this magical burst of creative inspiration before they can type a single word.
Like the muse has to strike them in the lab.
Right. But scientific writing is not a creative art form. I mean, it is highly formulaic. It is driven by specific blueprints and rigid expectations.
And honestly, for you listening, knowing that formula is the ultimate shortcut. Whether you are, a master's student trying to get your first publication, a clinical fellow, or just a curious learner wanting to understand how scientific knowledge actually makes it out into the world, you don't need a muse.
No muse is required.
You just need to know the rules.
But before we can get into the structural rules of the actual manuscript, we have to address the behavioral rules.
Right, the psychology of it.
Yeah, because you have to actually get the words out of your head and onto the page. The sources emphasize that the habit has to come before the formatting. So rule number 1 is scheduling your writing time as a non-cancelable appointment.
A non-cancelable appointment. I love that phrasing because you cannot wait around for free time to magically appear on a Friday afternoon.
It won't. It never does.
Never. You have to treat a 1 to 2 hour writing block exactly like a meeting with your principal investigator or, a doctor's appointment.
Yeah, one of the sources highlights this great example of a graduate student who blocked out 8 a.m. to 9 a.m. every single day.
Wow, every day.
Every day, writing in a completely empty lab. And getting that heavy cognitive lifting done first thing in the morning provides this massive psychological win that just carries you through the rest of your day.
Okay, wait, let me push back on that for a second. If I'm writing at 8 in the morning and what comes out on the page is absolute garbage, isn't that just going to ruin my motivation for the rest of the day?
Oh, I totally get that fear.
Because sitting down and forcing out terrible writing sounds incredibly demoralizing.
It does sound awful, which is why we have to talk about the cognitive mechanics of drafting. Rule number 2 is that you never start by trying to write perfect paragraphs.
Okay, so what do?
You start with a messy outline. You create your standard manuscript folders, so introduction, methods, results, discussion, and you just start dumping raw ideas and visuals into those buckets.
It's just a total brain dump. Paul Sylvia has a fantastic quote about this intimidation factor, actually. He says that for some people, it's easier to embalm the dead than to write an article about it.
That is painfully accurate.
Okay.
And that intimidation happens because researchers try to edit while they draft.
Oh, yeah, the constant backspacing.
Exactly. From a neurological standpoint, drafting and editing require 2 completely different brain functions. When you draft, you're using the brain's creative, generative networks. But when you edit, you're using the executive control network to critique and filter.
So they fight each other.
Right. If you try to do both at the exact same time, you cause massive cognitive overload. You freeze.
Sylvia compares editing while drafting to drinking decaffeinated coffee in the early morning. I mean, it's a noble idea, but it is the totally wrong time for it.
That's a great analogy. You have to bypass that critical filter. Mentors literally call this the shitty first draft.
The shitty first draft, trademark.
Yeah, you forbid yourself from fixing typos or rewriting awkward sentences.
Yeah.
You value the draft simply because it exists, not because it is good. I mean, you can polish a rough draft, but you absolutely cannot polish a blank page.
Right. Okay, so let's say we've surrendered to the messy first draft. We have our outline. Where does the first word actually go? Because if I open a document and try to write the title and the abstract first, I'm just staring at a blank page again.
That is a massive trap. You have to utilize a nonlinear drafting method. You never start at the beginning. Never. You almost always start right in the middle with the materials and methods section.
Okay, that makes a lot of sense, actually, because it's the freshest in your mind. I mean, you just spent a year actually doing the physical work. It requires the lowest cognitive load to just, describe the equipment you use.
Exactly. It breaks the writer's block immediately.
Right.
But while it's the easiest section to start with, it comes with a strict rule, and that is rigorous accuracy and replicability. You are basically writing a recipe for another scientist halfway across the world who needs to replicate your work exactly to verify your findings.
The sources show a great contrast here. Like, you cannot write a vague sentence like, bacteria were pelleted by centrifugation.
Yeah. That gives the reader absolutely nothing.
Right. You have to specify the exact parameter. So you say, bacteria were pelleted by centrifugation at 3000 G for 15 minutes at 25 degrees Celsius, because those variables dictate whether the experiment works or fails.
Spot on. And there's also a very specific stylistic quirk in the methods section that you need to know about.
Oh, right. The voice thing.
Yeah. Throughout most of a modern scientific paper, active voice is increasingly preferred. So saying, we measured the temperature. But the methods section is the lone holdout where passive voice still heavily rules. You write, temperatures were measured.
But why keep the passive voice there if we're trying to make writing more engaging everywhere else? It feels so dry.
It is dry, but it creates a sense of universal reproducibility. It keeps the focus squarely on the experiment itself rather than on the experimenter. It subtly tells the reader, it doesn't matter that I did this. If you do this, you will get the exact same result.
Okay, that makes perfect sense. So once those procedures are locked in, the nonlinear method moves us straight into the results section.
Yes, moving right along.
And I like to think of the results section like a very strict courtroom. You are only allowed to present the objective, naked facts. You completely strip out any editorializing.
Yes. Those editorial intensifiers are actually quite dangerous to your credibility.
Wait, really? Like what?
Like if you write, Table 3 clearly shows this massive trend. You are emotionalizing your claims. It signals to a reviewer that you are trying to force an interpretation rather than just letting the data speak for itself.
Oh, wow. So no, clearly no, obviously. But presenting the objective facts doesn't mean presenting all the facts, right?
Yeah.
I mean, if I ran a complex assay 20 times, I might have thousands of data points.
No, definitely not all the facts. Selectivity is the most critical skill here. You must distinguish between your results and your raw data.
Okay, so what's the difference in this context?
You are curating the findings that actually answer your research question. And you're filtering out all the peripheral noise. Nobody wants to read your raw data spreadsheet.
Right, and a big part of that curation relies on the visuals. Your figures, your graphs, and your tables have to be able to stand entirely on their own.
Absolutely crucial.
A busy researcher should be able to look at your graph, read the caption beneath it, and understand the core finding without ever having to dig through, like, paragraphs of body text to figure out what the axes mean.
Exactly. So now we have the core structure. We have the methods telling us what you did. We have the results telling us what you found.
But facts don't speak for themselves. We have to tell the reader what those facts mean for the real world, which brings us to building the frame around the data. We finally go back to write the introduction.
Yes, the frame. This is where we rely on Swales and Feek's famous three-move approach.
I love this concept.
It's great. It's a deeply ingrained formula that readers unconsciously expect. So, move 1. Establish a research territory. You zoom out and show why the general area of study is important, anchoring the reader in familiar literature.
Like setting the stage. And then move 2 is finding a niche. You point out a very specific gap, a problem, or an unresolved puzzle in that territory. You are essentially creating a knowledge vacuum for the reader.
And that vacuum is exactly what makes them care about move 3, which is occupying the niche. Right. This is where you outline your specific objectives and explicitly announce your principal findings to fill the exact gap you just created.
It's funny how many early career researchers treat their papers like a murder mystery, though.
Oh my gosh, yes.
They try to hide their main findings until the very end of the paper to build suspense. But readers of scientific papers are not looking for a plot twist.
No, they don't have time for a plot twist.
Yeah. They want the spoiler right up front. They expect the explicit purpose of your study, a sentence starting with, the purpose of this study was to be sitting right at the end of the introduction.
Yeah, if you hide the purpose, the reader spends the entire paper confused about why they're even looking at your data. So the introduction sets up the question, the methods and results answer it, and then we move to the discussion section.
Which always feels intimidating to me because it's the most open-ended part of the manuscript. How do you structure a section that is just supposed to be, like, talking about the results?
Well, you use structural symmetry. The discussion is simply the mirror image of the introduction.
Oh, interesting. Mirror image how?
Think about the flow. In the introduction, you zoomed in, going from a broad general background down to your highly specific research question.
Right.
In the discussion, you reverse that. You start with a tight summary of your specific findings, and then you gradually zoom out. You compare your results with what others have published, you explain any discrepancies, and connect your tiny puzzle piece back to the broader landscape of the field.
I see. And part of that zooming out requires being totally forthright about your study's limitations, right?
Yes. Do not hide your limitations.
It is so tempting to hide the flaws, like the small sample sizes or the boundaries of your assumptions, because you just want the paper to look perfect. But openly acknowledging your limitations actually builds your credibility.
It really does. It proves to the reviewers that you are an objective scientist who understands the boundaries of their own data, rather than a salesperson trying to overhype a result.
Exactly. Transparency is always the strongest strategy. So you finish that discussion with your take-home message and future directions, which leaves only one piece of the manuscript left.
The abstract.
The punchline of the nonlinear drafting method. The section that appears very first in the published paper is written at the absolute end of the process.
Yep. It is a tight, economical distillation of everything else you've already finalized.
So you finally have a completed, structured draft. You might feel like popping champagne at this point.
Hold off on the champagne.
Right. Because sending a brilliant manuscript into the void of the wrong journal just makes it completely invisible. It is a recipe for an instant rejection. Strategic matching is just as important as the writing itself.
It really is. You have to start by defining your paper's identity and its audience. Are you writing for basic bench scientists, clinical practitioners, policymakers?
Who is actually going to read this?
Exactly. And to find that audience, you can leverage digital tools like Jane the Journal Author Name Estimator.
Jane is amazing.
It is. You literally paste your title or abstract into the engine, and it algorithmically matches your text against millions of published papers to tell you which journals are actively publishing on your exact topic.
Or you can just look at your own reference list, honestly. The papers you cited are a map of where your community is already hanging out.
That's a great low-tech trick.
Yeah. I love how the International Union of Biochemistry and Molecular Biology, the IUBMB guide, breaks down this journal landscape. They personify academic journals into these 7 personalities to help you visualize exactly who you are pitching to.
It's a great framework. I mean, first you have the prestigious celebrity.
Right. This is your Nature, your Science, your Cell. They're walking the red carpet.
Flashing cameras everywhere.
Exactly. They have massive impact factors and incredibly high rejection rates. You really only pitch to them if you have a career-defining, paradigm-shifting discovery.
Yeah. Contrast that with the community leader. These are your specialized society journals.
The cozy ones.
Picture them wearing a cozy academic cardigan, exactly. The impact factor might be numerically lower than a celebrity journal, but the audience is highly targeted, deeply engaged, and the publication profit often go back into funding scholarships for your specific field.
Which is awesome. Then you have the innovator. Smart, casual, challenging old practices. They push for open science, transparent peer review, and publishing negative results.
Which is very different from the traditionalist. These are your classic, long-standing journals wearing, academic robes. They value rigorous, established standards and methodology over flashy new trends.
Right. Next is the blogger. These are the rapid, open-access journals, always a coffee in hand, moving fast. They are great for a quick turnaround, though the speed sometimes makes people debate the consistency of their peer review.
Yeah. That's the trade-off. And of course, you have the rest, the solid, dependable backbone journals of specific niches where the vast majority of good science actually lives.
But we have to spend a minute warning you about the sixth personality on that list, the shady thief.
Oh, yes. Beware the shady thief.
These are the predatory journals. They show up in a cheap suit, flooding your inbox with flattering emails praising your previous work. They promise lightning-fast publication.
And they can promise that speed because they aren't actually conducting peer review. They are just stealing your money with hidden article processing fees.
It's basically a scam.
Total scam. And publishing a good paper in a predatory journal can literally damage your reputation because it signals to hiring committees that you can't distinguish between rigorous science and a fraud.
Yikes. So you always have to verify a journal's credentials through indexes like the Directory of Open Access Journals.
Always.
The sources also give an honorable mention to the newspaper boy of the publishing world, which is the preprint servers like BiArcServe or Metarock. They stand in the town square shouting out your raw, unfiltered manuscript to the public before formal peer review even happens.
And preprints have fundamentally changed the publication ecosystem. They allow you to plant a flag on a discovery immediately, establishing priority, while also crowdsourcing feedback from the global community to strengthen the paper before you send it to a formal journal.
With all those personalities out there, you need a strategy to avoid getting stuck in this disorganized doom loop of rejections. You can't just pick one, get rejected, and then scramble to find another.
No, you build a submission waterfall.
A waterfall.
Yeah. Before you submit anywhere, you rank 4 target journals. You pick one aspirational target, maybe slightly out of reach. If it gets rejected, you already have your primary well-matched target lined up.
Okay, I like that.
Below that, a strong fallback, and finally, a safety choice. It takes the emotional sting out of a rejection when you already know exactly where the paper's going next.
That is incredibly smart. Okay, so let's say you've picked your waterfall. You submit to your primary target, weeks, maybe months go by, and then the email finally arrives from the editor.
The moment of truth.
Right. It's not a rejection, but it is a massive request for revisions. Welcome to the crucible of peer review. Honestly, reading those reviewer comments for the first time is one of the most emotionally charged defensive moments you can experience as a researcher.
It is incredibly stressful to have anonymous peers just tear apart work you spent years on. But here's the golden insight from the sources that you must remember in that exact moment.
What is it?
The quality of your response to the reviewers is often more important than the quality of your original submission.
Wait, really? More important?
Absolutely. A thoughtful, highly professional response package can turn a highly skeptical reviewer into your biggest advocate.
Okay, so that response package needs 3 very distinct components. First, a formal cover letter to the editor thanking them for their time and providing a high-level summary of the changes.
Very important.
Second, a bulleted summary of major changes so the editor can see the big picture without reading the whole document. And third, the main event, a detailed point-by-point response addressing every single comment from every single reviewer.
And William Stafford Noble wrote a foundational set of rules for constructing this point-by-point response. Rule 1, be incredibly polite.
Even if reviewer 2 is being awful.
Especially if reviewer 2 is being aggressively rude or dismissive. You remain strictly professional. Rule 2, make your responses entirely self-contained.
Meaning you quote your exact text changes and provide the new line numbers right there in the response letter. You do not make an unpaid, overworked reviewer hunt through your 30-page revised manuscript to find the one paragraph you fixed.
Exactly. You bring the evidence directly to them. And Rule 3, answer directly. Start your response with a clear yes, no, or a direct statement of the action you took before you launch into 3 paragraphs of background explanation.
Okay, but let me ask you this. What if the reviewer is just objectively wrong? Like, let's say I read a comment and they completely misunderstood a very clear, brilliant point I was making. Do I just smile, agree, and change the science?
No, you never compromise the science, but you do have to manage the psychology of the reviewer. Noble's rule here is essential. Accept the blame.
Accept the blame.
Yes. If an expert reviewer misunderstood your point, you have to assume that your original draft lacked clarity. You don't argue with them. You apologize for the confusion, you rewrite the section to make it undeniably clear, and you show them the revision.
Wow. That is a tough pill to swallow for the ego.
It really is. Which is why Noble has a brilliant psychological mechanism for dealing with that frustration. The 2-draft trick.
Oh, I need to hear this.
When you get those infuriating comments, you sit down and you write your first draft of the response. And in this draft, you let it all out. You use sarcasm, you vent your anger, you explain exactly why the reviewer has absolutely no idea what they are talking about, you write it all down.
And then you just immediately delete it.
You share it only with your co-authors. You use it as a pressure valve to purge the emotion. You have a good laugh about it together. Then you close that document, take a deep breath, and you write the second draft.
The real one.
The ultra-professional, polite, objective draft that accepts the blame and fixes the clarity. And that second draft is the one you actually submit.
That is genius. You get your ego completely out of the way so you can get the paper published. Because peer review is not about proving you are flawless, right? It's about making the final science as strong and clear as possible.
Exactly, which kind of brings us full circle.
Yeah.
Once you internalize these formulas and these rules, the paralysis disappears. It becomes a process of iterative refinement rather than a test of inherent genius.
From blocking out that non-cancelable hour in the empty lab, to forcing out the messy first draft, to navigating predatory journals, and finally surviving the emotional gauntlet of the two-draft trick in peer review.
We did it.
The overarching lesson from all our sources today is beautifully simple. Do not strive for absolute perfection, or you will never publish a single thing. You submit when the paper is good enough. Rejection, massive revisions, and moving goalposts, they aren't signs that you are a bad scientist. They are a completely normal, expected part of the machinery of disseminating knowledge.
Every single established scientist you admire has a folder full of brutal rejection letters.
Yeah.
It is just the cost of entry.
But I do want to leave you with one final, slightly provocative thought to mull over as you stare down your next writing project. We've just spent this entire deep dive establishing that scientific writing is highly formulaic. It's driven by rigid blueprints, passive voice in the methods, specific moves in the introduction, and highly predictable structural symmetry. If it truly is this mechanical and relies so little on abstract human creativity, how long is it until artificial intelligence completely masters this exact template?
Oh, that is the big question.
Right. Will the future of the shitty first draft be entirely generated by a large language model trained on these exact rules, leaving human scientists to simply act as the final peer reviewers of their own lab data?
That is the frontier we are looking at right now. Because the blueprint we just discussed is exactly the kind of pattern recognition that algorithms excel at.
It really makes you wonder what the role of the human author will look like in 10 years. Will we be writers or just editors? But for now, today, you still have to put the words on the page yourself. So the next time you leave the precise, predictable world of the lab and sit down in front of that glaring, empty white screen, don't wait for inspiration to strike. Just grab the blueprint, block out your calendar, and start building. Thank you for taking this deep dive with us today.
Keep writing and keep questioning.
Catch you next time.